Right, time for examples, Now I've gone over the binomial expansion, where it comes from. Let's see it put into practice. So, simple one, x plus 1 to the power 5. I've chosen a nice simple one because you can actually use Pascal's triangle to do it if you want. Okay? Or alternatively, just use the binomial expansion formula. I'm going to use the binomial expansion formula so you've got an idea of how it works. Now, do you want to use the top one or this one here? Okay? This is my preferred choice. Let's just go with the top one just for this example. Okay? So what you look for is n being the power, that is 5. Okay, so let's see what the power is. And then so you've got 5 choose 0. And then you've got x to the power of 5. Okay, as long as the x is there, of course, then that's correct. Okay, and then the next one is going to be 5 choose 1. And then you've got x to the power of 4. And then you've got y, which is just 1. You can either write 1 or just, because you know it's 1, just leave it. Okay, I did say to you earlier on that it's an easy case when 1 is one of the terms inside the bracket. And the next one, of course, will be 5 choose 2. And that would be x to the power of then 3. Notice how the powers are decreasing now. And then it would be 5 choose 3. Okay, x squared. And then you've got the dot, dot, dot bit here. But then you've got to know what the pattern is. Okay, as soon as you've got this far, you kind of work out what the pattern is. Okay, so 5 choose 4, x. And then 5 choose 5, and then x to the power of 0, which is just 1. Okay. Now, just work out what these are. All right. So 5 choose 0. There's a calculator function somewhere that you can use. Okay. So I'm not going to mention it in this video now, because otherwise it just makes it even longer. Try and find the calculator function. Okay. It might look like this: the n choose r function. Okay, on your calculator, in case you're trying to find it. Instead, that's another way of doing it. I've been brought up with the bracketed approach for the choose notation, in case you're wondering why I'm actually doing that. That's just the way I've been brought up. Okay. Anyway, so that is just 1 x to the power of 5. And then you work out 5 choose 1, that is 5, then x to the power of 4. Then you work out 5 choose 2, what was that again? Right, now I can't remember, okay? You might think, wow, he's only just done it. Yeah, I can't remember, so I'm going to work it out, okay? So 5 choose 2 is 5 factorial over 2 factorial, 3 factorial, okay? So that's 5 times 4 times 3 factorial on the top, and then 2 times 3 factorial on the bottom, and then cancel the 3 factorials. 5 times 4 divided by 2 is 10, okay? You know what? I lied, I did know what it was. It's just an opportunity to show you what to do if you can't remember. Okay? And then, what to do next? Okay, you've got to the halfway point, really. Because you think about it, there's an x squared term, an x term, and then the number. So the first 3 terms, then the next 3 terms. So think about the coefficients. It's going to be 10, 5, 1. So 10 x squared, 5x, and then 1. Okay. If you don't believe me, just work out what 5 choose 4 is, 5 choose 5, and 5 choose 3, you get the same. Okay. So there's an example using the top formula there. Okay. Right, get into a different type of example now. So we've got 2 minus x to the power of 4. Ooh, that's different, isn't it? Why is it different? Well, first of all, there's a 2 there instead of a 1. And also there's negative x as well. So this is going to be a little more challenging, isn't it? Okay. Right, so you can either use the top line again, but look, I'm going to start using this one here because you'll see it's actually quite simple to use. Now the thing is, that's always going to be 1, that's always going to be n, so look, these two are quite simple. Okay, just 1 n. So let's just do this. Now, make sure you get the order right, okay? The 2 is that one, and then negative x is that one. So when you're doing it, this term is going to be 2 to the power of n, which is 4. Okay? Then plus, right, n, remember I'm using this line here, n, which is 4, multiplied by the x term, the first term, if you call it, which is going to be 2, I'm going to put that in brackets, to the power of 3, then y, that is this term there. That is negative x. The important thing about the negatives is replace that with negative x, okay? And put it in brackets. You'll see why it's going to be important. And then plus the next term. So we've got 4 factorial over 2 factorial, and then 4 subtract 2, which is 2 factorial, okay? And then you've got this term, 2 to the power of 2, and then this term, which is negative x squared. All okay so far? Hoping so. And then you've got the next term, which is going to be 4 factorial over 3 factorial. And then that's going to be 4 subtract 3, 1 factorial. I tell you what, because it's just 1 factorial, I'll just write it like that, 1 factorial, okay. And then you've got 2, that's going to be power 4, power 3, power 2, power 1. And then the negative x is going to be power 1, power 2, power 3. Okay. And then the last term is handy if you remember this. The last term, the coefficient is always 1. Okay, so n choose n is always 1. If you remember that, it's quite handy. Right, so just remember that. And then so you just got 1, and of course you've got the 2 to the power of 0, which is always 1. So you've just got the negative x term to the power of 4. That is it before it's simplified. Okay. Make sure you're doing that step with the working as shown before you simplify. If you try and simplify as you go along, you'll get into a mess. Or some of you will. No, a lot of you will. No, most of you will. Okay, so try and actually write this line with the brackets as well. You can see why the brackets are important. Okay, because negative x all cubed is negative, but negative x all to the power 4 is positive. All the even powers here are going to be positive. Oh, that's not an even power, is it? All the odd powers, that's an odd power, they're going to be negative, okay? So when you simplify, it's 2 to the power 4, 16. Then 2 cubed is 8, times by 4 is 32. But then you've got negative x there, so let's subtract 32x. And then let's simplify this. So that's going to be 4 times 3 times 2 factorial. So 4 times 3, that will cancel the 2 factorial. 4 times 3 divided by 2, so that's going to be 6. Okay? Then times by 2 squared, 6 times 4 is 24. Negative x all squared is positive, so positive 24x squared. Okay. Now, little hint, when I write down each term, I normally think, is it positive or negative first? So doing the q term, is it positive or negative? It's negative, because we cube a negative value, we get negative. Then I work out the number, so 4 factorial over 3 factorial is just 4, and 4 times 2 is 8, so it's going to be 8, and then of course you've got x cubed. And the last term, negative x all to the power of 4 is positive, so positive x to the power of 4. Okay? And there we go. And then that's that one done. Okay, in this example I'm going to show you a really quick, super fast way of doing it. Alright, so here we go. 1 plus 2x to the power of 6. Alright, so start off with 1 to the power of 6, 1. Okay, and then n, which is going to be 6, and then x to the power of n minus 1. Notice this is 2x, so that's going to be 2x all to the power of 1. Okay, and then the next term, right, 6 times by 5 over 2 factorial, over 2 factorial, over 2. And then 2x squared. Then the next term, 6 times 5 times 4 over 3 factorial, which is 3 times 2. Then 2x to the power of 3. Next term, 6 times 5 times 4 times 3 over 4 factorial, which is 4 times 3 times 2. Notice I don't bother with the times by 1 because that's an obvious thing. Okay? And then 2x to the power of 4 plus. I'm going to stop there. Can you see how I've done that? Maybe just pause the video and just think about how I've actually been able to write those down. It looks like I'm not actually using any of these, but I am. It's just a quick way of doing it. Let's just take this one here, for example. Okay, so here, when you compare it, the n factorial is 6 factorial, isn't it? And then the 3 factorial, and then 6 subtract 3, which is another 3 factorial. Let's look at the simplification of that. On the top, you get 6 times 5 times 4 times by 3 factorial. And on the bottom, you've got the 3 factorial, and then another 3 factorial. But guess what? These 3 factorials cancel. Hence, 6 times 5 times 4, 3 times 2 times 1. Same with this one there. When you write this down, okay, you're going to get 6 factorial on the top, and you'll get 4 factorial on the bottom, and you're going to get 2 factorial as well. Well, I've kept the 4 factorial, 4 times 3 times 2, but the 2 factorial has cancelled with a a 2 factorial on the top if I write it 6 times 5 times 4 times 3 times 2 factorial. Okay. What I'm saying is there's a really lovely pattern to these that you can use to your advantage. And the pattern is this, okay? You've got n, and then for each term, 6 times 5, 6 times 5 times 4, 6 times 5 times 4 times 3. The next one, you've guessed it, I've run out of space, okay? Next one will be 6 times 5 times 4 times 3 times 2. And on the denominators, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Okay? Or 5 times 4 times 3 times 2. And then you've just got to put in the 2x to the power of 5. And then the next term, okay? 6 times 5 times 4 times 3 times 2 times 1. Over 6 factorial. But you know it's the last term. Whenever it's the last term, it's always just 1 as the coefficient. Okay? So I don't need to bother with all the factorial stuff. Okay? All I need to do is just put in 2x to the power of 6. Okay? That's done. If you didn't quite catch all of that, maybe just stick to using the formulaic approach. Okay? But some of you will be able to see the speedy quick method that I used. All right? And then you just simplify this. The annoying thing about Pascal's triangle and the binomial expansion to some extent, the annoying thing is trying to fit everything onto one line. It's like, oh, I want to get everything on one line, but yeah, a bit difficult, to be honest. Right, so 1, and then 12x, and then, right, let's just do this. So that's going to be 4. Let's divide by 2, so that would be 2, and then 30. Okay, so 30, let's do 60. See how I did that? Remember, when you expand brackets, 2x squared is 4x squared. Okay, hence 30 times by 4 divided by 2, or 30 times by 2, x squared. And then the next term, 2x cubed, that's 8x cubed. That's why the brackets are important, because you've got to do 2 cubed as well. So 8. Right, I'm going to cancel the 3 times 2 there with the 6 there, just to make it simpler. So you've got 8 times by 5 times by 4. 5 times 4 is 20. So you've got 8 times 20, 160. 160 x cubed. Right, next term. Right, 2 to the power 4 is 16. 16. Right, the 4 times 3, I can cancel those there. Okay, just think, I'm doing mental maths now. Okay, which is why I'm cancelling. The 2 there, I'm going to divide that by 2. So we've got 3 times 5, which is 15 times by 16. 15 times by 16. Right? 15 squared is 225. Add another 15, 240. So 240, x to the power 4. And then next term, this one here. 5 times 4 times 3 times 2. 5 times 4 times 3 times 2. Lovely. 2 to the power 5, 32. Times by 6. 32 times 2 is 64. Times that by 6. 64 times 6, 192. 192. X to the power 5. And then lastly, 2 to the power of 6. 64. 64 x to the 6. Done. One more for you. Here we go. 2 minus 3x to the power of 4. Maybe just pause the video, have a go yourself. Maybe you've been doing that all along, in which case, well done to you all. If not, well, start now. Okay. Right, I'm going to do the super speedy quick method again. All right. So, first of all, you've got here x to the n, 2 to the n, 2 to the power of 4. Okay. And then you've got n itself, which is 4. And then you've got decrease the power by 1 here, so 2 to the power of 3. And then you need the y term, which is negative 3x, don't forget. Just stop there. Just make sure you're happy with those first 2 terms. Okay. Right, the next time, plus. Now, you know what I'm going to do here? So here it's 4, here it's going to be 4 times by 3 over 2 factorial. Remember the super speedy quick method, okay? Check it if you don't believe me, but that coefficient is the same as that, okay? It's 6, basically. And then you've got x to the power of n minus 2, so it's 2 to the power of 2. And then you've got the y squared bit, which is negative 3x. And then that's squared, okay? And then the next term, so next, 4 times 3, so 4 times 3 times 2, over 3 factorial, which is 3 times 2. Again, if you're not too sure, check that. When you substitute in, you get the same as that. Okay. 4 is what you get. And then you've got 2 to the power of 1, so power of 3, power of 2, power of 1. And then you've got negative 3x to the power of, so 1, 2, 3. Okay? And then the last term, because it's the last term, you know it's a coefficient of 1. Okay? And then it's going to be negative 3x to the power of 4. Hey, you got it all on one line. That's because I chose power 4. Okay. When I go any more, like power 5, that's like I can't fit it all on one line. So I chose power 4 because I kind of knew I'd be able to fit it on one line. There we go. Then we just do the simplification. 2 to the power 4 is 16. After this, you'll be really good at your powers of 2 because it comes up quite a lot, doesn't it? Okay. And then here, so we've got 2 cubed, which is 8, and you've got 8 times 4, which is 32, times that by negative 3, so negative. So I want to say 32 times by 3, so that's 96. 96x. Right here, positive or negative? Positive, because negative squared is positive. Okay. And what have we got here? So we've got 4 times 3 over 2. I said that was 6, didn't I? It is 6. So let's just do the calculation. So 6 times by 4, that's 24, times by, that's going to be 9, isn't it? Yeah, so 3 squared is 9. So the way I'm going to do this, I'm going to do 6 times 9, because now it's 54, off the top of my head. 54, double that, 108, double it again, 216. I'll write it down before I forget it. See what I did there? I just, times by 4 is easy, double it twice. Okay, so 54 times by 2 times by 2 again, 108, 216. And let's not forget the x term, x squared. Then moving onwards, okay, so let's just cancel those first, 3 times 2's. And the 3 cubed there is 27. This could be negative, isn't it? So let's just put a negative there. I'm going to expand the brackets. So you've got 27 times by 2 times by 4. So 27 multiplied by 8, isn't it? Okay. So when you multiply by 8, double it 3 times. Times by 2, times by 2, times by 2. 2 cubed, 8. Okay. So 27, 54, 108, 216 again. 216 x cubed. And then lastly, 3 to the power of 4. 3 times 3 times 3 times 3, 9 times 9, 81. And it's positive, so plus 81 x to the power of 4. Done.